ఉన్నారా? ఓకే. సర్లే ఇది కంబైన్డ్గా చేయొచ్చామనుకున్నా, హ్యాంగ్అవుట్ ఎయిర్ అండ్ దానిలోనే మీరు ఉంటారేమో అని, బట్ సెపరేట్గా వస్తుంది. దట్స్ ఫైన్, రికార్డ్ అవుతుంది ఎనీవే. ఓకే, సో లెట్ మీ షేర్ ద స్క్రీన్. ఓకే, కనబడుతుందా ఇప్పుడు? ఓకే, starting with Spring framework. So first, what is Spring? Okay, so we'll go by this. So basically, Spring framework is a lightweight framework. So in the sense, we talked about lightweight and heavyweight right before. So what is the context where we talked about lightweight and heavyweight? Do you remember? Threads. Okay, what is that? Threads లో ఎక్కడ?
Thread is a lightweight అని మనం. Thread is a lightweight కదా.
Okay, then what else is heavyweight? Process is heavyweight, right?
Process is heavyweight.
Yeah. So basically, whenever, like, whatever operation you want to do, basically, like, if it is involving so much so many resources, and there, like, you call it as heavyweight. For example, for process, you have to start a new process, means basically you have to add a new address space, right? To have separate JVM and all. So where, like, you will be this will be intense, resource intensive. So that's why it is called a heavyweight. So compared to that, thread is basically, it's spawned out of another process where you already have some address space allocated, and thread will be sharing that space, right? So in that way, it is called lightweight. And also we talked about heavyweight and lightweight on one more occasion. So difference between AWT and Spring, right? Do you remember? AWT is basically heavyweight because it is going to use resources of the local operating system, right? So for look and feel, for display, whereas Swing, it will have its own native look and feel, right? So where you can provide like a layer of look and feel, so where it doesn't use resources of operating system, that's how it is called lightweight, right? So wherever you have less number of resources that are used, so that framework is called lightweight. So here, similar to that, you can call Spring as lightweight framework. So, and this is also called framework of frameworks, because it provides support to other various frameworks like Struts, Hibernate, Tapestry, EJB, JSF. So basically, I don't know if you heard about these frameworks. Like, probably you heard about the names, right? So similar to Spring framework, we have Struts. So that is also used for developing web-based applications. So we had Struts before we got a Spring framework. And Hibernate is basically for dealing with database related operations, relational mapping, ORM or ORM tool, or persistence layer or persistence framework. Means basically we'll be dealing with database, and it makes it easy for the developer for writing queries and all, like, how to deal with database. And Tapestry, this is something I don't know, I forgot. I never worked with this. EJB, Enterprise Java Beans, this is also another framework that you will be using in web-based applications. And JSF, Java Server Faces, this is also another framework. So basically, Spring can be used in combination with these frameworks. Okay. So whereas these frameworks don't offer anything to other frameworks, but here Spring framework offers something to these frameworks, so that you can have a combination of Struts plus Spring in a web application, or you can be having a combination of Spring and Hibernate, or you can be having a combination of Spring and EJB. It can be used in combination with any other frameworks. So such a useful framework it is. Okay. So And yeah, one more thing, like it comprises mainly, again, as we are saying, like it provides many functionalities. So means we are not keeping everything in one thing. So whereas like we are dividing Spring Framework into multiple modules. So again, modular design is a good way, right, where you don't have to have everything. Like if you want to have only certain functionality, so you can simply attach that module and get the functionality. So you don't have to have everything, right? So if you don't have modular based design, then you will have to, like if you have a jumbo product, then you need to attach that jumbo product even though you need a specific piece of it. So so here Spring Framework comprises several modules such as IOC, which is inversion of control. This is such an important concept in Spring Framework, and I'm sure, like if you claim that you have experience with Spring Framework, so there will certainly be a question on inversion of control or IOC. For sure, like if you explain IOC very well, then they will think that you have some kind of experience with Spring Framework. So if you don't explain, or if you if you make blunder with explaining IOC, then they will know that you don't have any experience, like zero experience with Spring Framework. Such an important concept, and such an important item for interview question. And AOP, aspect oriented programming, it's another module. And DAO, data access object, this is also another one module which is widely used in detail. And context, this is also another module, like ORM, web, MVC, etc. So there are many modules in Spring Framework, and depending on what you need, you can use a particular module. So you might be using multiple modules sometimes, so you need to attach multiple modules into your project, and then it working. Any questions until this point before we move on to individuals? Okay, Lalu. Still have any questions? Let's understand IOC dependency injection first. As I said, this is the foremost concept. So in Spring Framework, so you need to be understanding this very well. So as I said, it's okay if you, if you don't know some modules, because not every module, but at the minimum, so bare minimum that you need to have, is the core module, basically, which will contain IOC and dependency injection. These are the design patterns, so you can call them as design patterns also. So I told the meaning of design pattern, right? So do you remember what is design pattern? Why we call design pattern? Why we have that name? Do you remember singleton, and what else we discussed? Huh? Executor pattern, yeah. Do you remember why we call design pattern? Because this is something which has been tested and which has been working, and which can be used simply without much thinking into it. So so you can this is something you can reuse. It's a kind of reusable component, right? So here IOC and DI or dependency injection or some other concepts which you can use again and again. You can just simply follow the implementation of those, and you can get whatever the functionality that these are intended for. Also called design patterns. Okay. So they make code easier to test and maintain. Of course, yeah, that's one of the core functionalities. So let us understand. Okay, let us go with a sample. So that's how we can understand the concept better. So we have a class employee. So under class employee, let's say employee has address. So then you have address variable inside. Then I have constructor empty, and address equal to new address. To get address objects, I should be creating a object of employee, right? So without creating employee object, I cannot get address object, right? So because they are dependent on one another, right? right? Can I create the address object with such implementation? Can I have address like, you know, basically, let's say I want to create an employee information with address information attached to the employee. So with such implementation, so first, in order to get address object, or in order to load address information into the object, I should be creating object of employee, right? So you can say this is tightly coupled. So means you cannot separate them out, like, you know, you cannot treat them as independent entities, like employee and address. So this is like, you know, they are tightly coupled. So when you create employee object, then only inside address object will be created. So you cannot say if you want to create only address object independent of employee, you cannot do that with such implementation. So this is called tightly coupled. Then means they're basically so dependent on each other. In such a case, there is a dependency between employee and address, right? Tight coupling, that's what we are talking about. Then the inversion of control scenario, you know, the one that we are discussing and that we said, which is very important in Spring. This concept is, again, it's part of Spring core module. So one of the modules is core, and this concept is part of that. We do this something like this. For example, like if you look at the code is employee and address variable, employee address, this address equal to address. Are we creating address object here? In this code, are we creating address object, or are we simply assigning the value of address the local variable? Hello?
We are creating address object and
No, we are not creating address object inside. We are just assigning. So address object should be created outside. Let's say I have a test program with a main method where I'm creating employee object for employee class. There for constructor I'm passing address object. Means address object will be created before, then employee object will be created, and to the constructor I'll be passing address object, right? So within the employee object, I'm basically just passing the value, means injecting. So this is kind of injecting address object into employee, right? So basically they are created separately, like, and it's a kind of loosely coupling. This is called loose coupling. Means they don't have direct dependency. So even, like, you know, if you have empty address passed, still you can create a employee object, right? Let's say I have in test program employee equal to new employee of null, or if I say, like, even I can say new employee of empty constructor, still employee object will be created even though I'm not having address object assigned or created, right? So did you get the difference between these two code pieces? So here I'm keeping the creation of address object tightly coupled, like, you know, and when I create employee object, then only address object will be created. So it's a kind of keeping that object inside, means I cannot use that object anywhere else. It can be used or accessed only within the employee. It's a kind of, I'm keeping a tight coupling between those two, like dependency. But here, whereas here, I'm just injecting address object. I'm creating basically injecting. Injecting means creating address object separately and then injecting into this. So this way you can inject same address object into some other employee also, right? If you want. So that's how, like, you know, you are keeping this loosely coupled, means not keeping as a dependency. So this is done by IOC, the inversion of control. So which is basically fashioned way, like, you know, we used to have this way before, now we changed it to this. Okay, is the concept clear, Lalu? Yeah. I mean, this may be a bit confusing, but if you read it again, a couple of times, then you'll understand. So here again, in such a case, there is no need to modify the code if our logic is moved to new environment. Okay, this is confusing. Okay, just forget. Anyway, you got the concept right. In Spring Framework, IOC container. So we talked about Spring Servlet container, right? For servlets, for running servlets, you need servlet container because web server itself is not enough. Like the way you have servlet container for running servlets, if for running applications which are based on Spring Framework, servlet container is not enough because you are having this extra functionality. The regular old-fashioned way is not doesn't work. So you need IOC control container that can only run Spring-based applications. So then you can ask, like, what kind of web server or application servers will be used for running this Spring. So you can Apache Tomcat is also IOC container. So where you can run Spring-based applications inside. Okay. So the Tomcat that you're using, that is servlet container as well as IOC container. Means it has got functionality for running servlets as well as Spring-based applications. Okay. We provide so IOC container is responsible to inject the dependency. So who is responsible? So in case of IOC container, you will be defining Java, like creating Java objects. Then IOC container will take care of injecting. So we'll just explain. We'll go through an example, then you will understand fully. We provide metadata to IOC container either in the form of XML or annotation. So like the injection way, we have a different way in IOC container. We'll explain when discuss about example. Advantage of dependency injection. So what is the advantage? So it makes code loosely coupled, so easy to maintain, right? So easy to maintain, basically when you define an object, you can use it at multiple places, or you can inject into multiple class objects, different objects. Let's say here, okay, let's go by this. Here, if I create one employee object, what happens inside one object, address object will be created. So if I create employee 2 objects, then again one more address object will be created inside, right? But whereas if you have same address for 2 people, let's say I have employee John and Jesse, so for example 2 people, and 2 people reside at the same place, so they might have same address. So using this approach, you will create an object for John, then John will have address inside that will have 123 street, for example. Then Jesse will also have the same address, so it will have different object inside, so which may not be necessary. So in such a case, one address object should be fine, like separately one address object 123 street, and you can inject that to both the employees, right? So in that case, the second example would be better, right? So like defining one object and injecting into multiple other objects. The injection and all will be taken care by IOC container. So there is like you can either specify an XML file or annotation, and injection will be taken care by IOC container. So again, makes the code easy to test. These are the advantages of DI or dependency injection. The advantages of Spring Framework overall. This is only like DI is part of core module, right? But you have got many other modules. So total advantages of Spring Framework. Many advantages basically. Predefined templates. Normally, okay, for JDBC, when we practiced a program, we had to create connection statement and all that, right? All that coding. So you don't have to do all that using Spring Framework. Spring Framework provides templates. So this is called templates, like for JDBC, Hibernate, JP, etc. For all different frameworks or different package or concepts, it will provide some templates. So there is no need to write too much code. So you don't have to write all the code where you say connection, statement, and all that. It hides the basic steps of these technologies, because that is like pretty standard, right? How many other examples that you tested? So in every example, you are loading driver, you are getting connection, getting statement, and all that, right? So that's repetitive. So why should we do that? Why not let the Spring Framework do it for us? So let's take example of JDBC template. For example, for JDBC, the one that we did before. So you don't need to write code for exception handling. Again, you're writing code for exception handling, right? For catching SQL exception and overall generic exception like exception, right? Like if your connection is, if you are not able to get connection, or if there is issue with network or something else, then
exceptions.
checked exceptions. You are catching exceptions like SQL exception or exception. So this is like pretty much standard, and why you should write all this every time, and every time you write a JDBC program. So these things will be taken care by this framework. Like framework provides in terms of in the form of templates, like JDBC template for JDBC related things, and creating connection, creating statement, committing transaction, closing connection. These are all like repetitive things. You don't have to do all this. You need to write the code of executing query only just query execution, because that's where you need to mention table and what kind of query, right? That's the only thing you have to write, because it saves a lot of JDBC code, right? So this is this is achievable, or it's using predefined templates like JDBC template in this case. Similarly for JPA and Hibernate, it provides some templates and classes which can be used for some repetitive stuff. What is that other advantage? We already discussed loose coupling. String applications are loosely coupled because of dependency injection, right? So you got this basic understanding, right? What is DI, dependency injection, and what is loose coupling? Easy to test. Dependency injection makes easier to test the application. EJB or struts application requires server to run the application, but Spring Framework doesn't require server. Okay, so anyway, it's easy to test because of this concept. Lightweight, again, we talked about. Spring Framework is lightweight because of Pojo implementation. Pojo is plain old Java object. So we talked about Pojo or Java Bean, right? What is Java Bean? So Java class with the getter some fields and getters and setters, right? Yeah, that's a Pojo, plain old Java object. So basically, mostly Spring Framework uses every class that you define. For example, if you identify like student, employee, and department, all these classes. In all those classes, you will define variables and you will have getters and setters. So that way you can easily get information for a particular field, also set information. Spring Framework doesn't force a programmer to inherit any class or implement any interface. So they'll be like plain, simple Java objects where you are not extending any class, where you are not implementing any interface. So if you do all that, then you'll have to inherit the methods and then provide implementations and all that, right? So then throw exceptions, if there are some which are part of those classes or interfaces. So you don't do all that, simply define a class like class ABC, and inside you define some variables and provide getters and setters. That is why it is said non-invasive, you have all separatable, separable or can be separated Java objects with simple getters and setters. Fast development, DI pro feature of Spring Framework and its support to various frameworks makes the development of Java EE application easy and fast. Powerful abstraction. It provides powerful abstraction to Java EE specifications such as JMS, JDBC, JP, and JTA. So abstraction means, again, what is abstraction? You don't know the internal details, but you still know just what kind of functionality it provides. For example, if you have a method, by name or by descript, by information, what kind of functionality it provides. You don't know the internal implementation details, right? So still you can be able to use that function and get what you want. So there are different packages or modules JMS, JDBC, JPA, JTA. There are many functions internal details we don't know, but just by name or by the documentation we just get all the functionality working. We can implement whatever we want. Similar to for example, we discussed about JDBC template in JDBC. So we don't take care of connection and all that. we simply call the query like an execute query and get the information as if we are working in a SQL ID and where we are executing like select star from EMP. Declarative support provides declarative support for caching, validation, transactions, and formatting. Topics. So these are like few advantages of Spring Framework. Any questions with advantages? Then again, as I said, like there are multiple modules. So if you look at the picture, this is very clear. Like it's a grouping also. I mean, related related modules are grouped together like this. So JDBC, we talked about JDBC module, right, to some extent. ORM, object relational mapping, and OXM. What is OXM? There is a form for this. OXM, object XML mappers. Okay, for converting XML to Java, Java to XML, I think. Okay, we'll discuss like later. Like I mean JDBC, ORM, OXM, JMS transactions. It's like we are dealing with database here. JDBC means ORM again object relational mapping. So instead of writing JDBC queries directly, this will provide some intermediate the in between layer or API where you can use those functions and write. I mean, I can be able to communicate with the database in a simpler way. OXM, JMS, Java messaging service. So again, this is like this falls under database related or data access and transactions. So all these are falling into like 5 modules are falling into one group. So that is like a data access or integration. And we have some more modules: web, servlet, portlet, struts. So even Spring Framework provides a struts module also. This is called web MVC or remoting. So this is mainly for web development, these modules. Then we have AOP, aspects instrumentation. These are mainly for aspect oriented, like for logging and all. We'll discuss about that these later. Then Spring Core container, core beans, context, expression language, test and test. Spring also provides a module for unit testing like JUnit and TestNG. Provides support of testing with JUnit and TestNG. So looking at these, like in these modules and such a jumbo product, it is like Spring is such a jumbo product where you have everything that a programmer would need for doing for getting a web development, right? Right. If you think of any web development or web application, so basically what you will be doing, like basically you will be developing like a servlets or server side program where you have web and servlet, the modules, and then you have a database where you have to normally you will have to write JDBC programs, but Spring gives you like it provides some modules where you don't have to write each and every thing. Basically you just have to execute queries. So for that it provides data access related modules. And for the unit testing it provides JUnit, TestNG kind of support. Then it provides dependency injection and IOC. So with that, like the development will be faster, and it has loose coupling, and where you can use the beans again and again, like at multiple places, right? It's like a reusable code. Check expression language. This is basically like you have in JSP you have EL, right? Expression language. So do you practice EL for JSP? Okay, you can try that. Like okay, this is for like basically we'll talk about it later. This has got more. So whatnot, like Spring Framework provides everything, right? So yeah, everything that you need for web development. And Spring Core container. Spring Core container contains core beans. Here you have these modules: core beans, context, expression language modules. Core and beans, basically these are modules provide IOS and DI features, dependency injection. So as we discussed before, so these provide IOS and DI are provided by core and beans. Beans is basically for defining POJOs. Core is basically which will provide IOC, where IOC container will inject one bean into another, right? Context. This is one of the modules here in Spring Core. Context. This provides internationalization if you want to develop your application in multiple languages. So this provides support. And EJB JMS basic remoting. Expression language, again here it's extension to EL defined in JSP. Provides support to setting, getting properties, values, method invocations, some stuff it provides. AOP aspects, instrumentation, these modules support aspect-oriented programming implementation where you can use advices, point cuts. So we'll talk about these later. This supports to integration with aspect chain. Then data access and integration, we talked about this. It mainly consists of JDBC, ORM, OXM, JMS transaction. These basically provide support to interact with the database. That's what we talked about. Web, this is the main one. This comprises of web servlet to portlet to struts. These provide support to create web application. So then creating Spring application. So here, just check what are required to create Spring application. Just here. So we are not talking about any IDE like Eclipse or anything. So simply let's say you don't have anything, and what you need for creating Spring application. First, create a class like a POJO class. Okay. The 5 steps basically. POJO class, as I said, you can define a simple class like student, and student has name here, just one field. So this should have getter and setter, get name, set name. And I have one more method for displaying information like hello name. Okay, it's a simple student class with just one field name. Okay, so that is clear, right? So one simple class. Now, so we talked about dependency injection, right? How IOC container injects values. So this is we have this application context XML file. So we said either we can be providing a DI using XML or annotations, right? So here we are following this XML way. So you'll define something like this. You don't have to remember all this. So here you say beans, means all the beans that I can use multiple times, again and again, and the beans that I can inject into other beans. Okay, so these I'll be discussing like this. All the beans. Here I have one bean, student bean. You can name anything. You can give any name for ID. Then class is Java point student. So this is a class. And property, how many properties it has? One. And value. So this one. So if you in a regular way, basically what you will do to assign a value to name, you will define new student, then student dot set name, right? That's how you define inject assign values, right? So if you do that, then it's new student and then student dot set name. So means you'll be setting the name, and if you want to define one more student, then you will be defining new student and set name again, right? So here, whereas we are separating out, instead of tight coupling, we are doing loose coupling. Just define the values for student like this. So defining this bean separately, a loosely coupled, whereas if you want to use this student bean at multiple places, if you want to inject, let's say, if you want to inject student bean into other class objects, you can easily inject, by defining it only once, like this. So basically, IOC container would expect the bean information to be kept in application context XML file. That's how it will invoke or instantiate this bean and assign a value for the name. So now once you start your application, so you will have student bean created with name assigned as this. Okay, they're creating a test class. Now I got a student class defined here, and then XML. In XML, I'm creating an object for student. So I have got my student object ready. Now in the test, in the main method, I have resource class path resource application context XML. So basically, when you run this program, so you will be loading this XML where you will be instantiating student bean and assigning a value to student name field, right? Then bean factory, you have like in this one where you will be executing, like here you are creating a object, and then basically you are loading means creating a bean factory. So this bean factory will have student bean. So the name is itself tells, like bean factory means it's a factory of beans. So here I have one bean, whereas like we can define one more bean like this here, like here. So then I'm getting a bean from the factory. So again, this is another design pattern. We talked about factory, right? Factory can have a connection of like pool of threads or pool of database connections. Similarly, we can have a factory that can hold multiple beans. You can have a bean factory. So here get bean, how many beans, like by mentioning the name of the bean, we are getting the student object here. That's a bean. Then we are displaying information. So it will display welcome or hello and that name. Okay. Then load the jar files. Again, what concepts we are using from Spring Framework here in first 3 steps? Tell me what concepts we are using. What modules, I mean. Dependency injection for sure, right? Dependency injection for sure. That's basically DI and IOC and beans, right? Right. So beans, we defined a getter setter of bean, right? So for dependency injection and IOC, we need core. So we need to get jar file, right? That's how we can get the API functions of that, right? So we have a jar file for core. That's how we get a core module. And we have these beans. That's how we get Apache Commons logging. Of course, we are not using any logging, but maybe like it would use logging internally, like when you start application, then it might log some information, right? So logging, logging, what is your logging? Do you know? So basically, okay, let's say if you are writing a program, then if you want to know like what's happening at different steps, then you will keep system.println, right? So it's like basically that is basically for information purposes, like to see what's the flow and what is happening at different points in the flow. So like that is called logging, and we use like some